morning, geometry, or good afternoon, whenever you're watching this. We are going to be looking over our 8-2, what we just did on Friday a week ago. And then what I want you to do is I want you to take your homework that you had the other day, and I want you to snap a picture of it and email it to me. You should have, if we would have had school, you would have turned it in on Monday, but since we didn't have school, then you couldn't turn it in. So snap a picture of that and turn it in. I'll leave instructions for you to do that. But I'm also going to give you homework today on IXL. There's some great IXL lessons on trigonomic ratios, and I will leave instructions on how to do that. If you have forgotten your password since we haven't used it in a long time, then please let me know, and I will make sure that I get you that password. So we're going to briefly go over examples 1, 2, and 3, what we did before, and then we'll spend a little bit more time on example 4 and 5, which we didn't touch on Friday. So our objective, find the sine, cosine, and tangent of an acute angle. Use trigonomic ratios to find side lengths in right triangles and to solve real-world problems. So there's our vocabulary that you should have already done. So SOHCAHTOA, we're remembering SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So chant with me, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. That will help you so much when we do these ones here. Okay, so let's just briefly remember these. Sine, and then cosine, which is ka, and then tangent, which is toa. So sine, opposite, we're looking at J. So opposite over hypotenuse, 60 over 61, and that equals 0.98. And then cosine of J, which is adjacent, so we have 11 over hypotenuse, which is 0.18, if you remember that from the other day. And then TOA is our tangent, so we have our opposite. We're looking at K this time, so I'll change colors here. So opposite is 11 over our adjacent, which is 60. And that comes out to be the 0.18, the same thing. So hopefully that is a review from last Friday's lesson. But if you need to, you can go back and look at it again and pause the video, rewind, all that kind of stuff. Okay, so if you want to try some, I know we did these in your notebook, but you can pause the video, you can try them, you can check your answers. But again, these should be in your notebook, so if you need a review, you can go back and look at those. So I'll give you a minute if you need to pause the video. And then here are the answers. Hopefully this is just bringing back all review for you. So these were our special right triangles. So this one's our 30, 60, 90 because it's cosine of 30 degrees. So then we solved this one as, so we have cosine, which is ka, so ka, which is adjacent, so adjacent, the one next to it, over the hypotenuse. So s times the square root of 3 over 2s, and we can cancel that out, and we're left with the square root of 3 over 2 as our answer. In these cases, don't try and simplify it any more than that. We want to leave it with the radical sign. Okay, and then this was the one that I gave you guys to do. So if you want, pause the video now and solve it. So if you pause the video, tangent is TOA, so opposite over adjacent. So opposite over adjacent. So S over S, which just equals to 1. Okay, these ones, just find your calculator. So one thing I do want to remember I want to remind you of is when you're doing these, you need to have your, well, here's the cosine of 19 degrees. So hopefully that matches up with your calculator. As we look on this slide here, I do want to bring your attention again over here to this. Be sure your calculator is in degree mode, not radian mode. So how do you know whether or not it's in degree mode? Well, you click on, for most of you, you click the mode button. And once you click the mode button, then you click on, you go down, I think it's either the second or third one says degrees or radians, and you make sure that degrees is highlighted. It's got the little box around it. If it is, then you are good to go. So then you just type in, you just click sine of, you click sine of 52, and it comes up with your answer. If you're doing it on your phone, which I have figured out, it's actually the opposite. You type in the number 52 and then you click sine, and then it gives you the answer. So these are the answers to this. These are the answers to this one here: 0.79, 0.95, and 2.14. So hopefully they match up with what you have on your calculator. If you want, take a pause, take a minute, solve these ones using your calculator, again, just to make sure that your calculator is in degree mode and not radian mode. But if you pause the video, here are the answers for these ones. There we go. Hopefully they match up with what you guys got. Okay, so here we are. We are going to find our, let's go back to, I'm going to do, let's just do that. Okay, so this one is, we're using trigonometric ratios to find lengths. So this is the one we have not done yet. So we've got our handy dandy 15 degrees here, and it says find the length of BC. So we're going to find the length of BC here. So we have to look at, from our SOHCAHTOA, what do we have and what are we looking to find? So in this case, we do not have our hypotenuse. As you can see, we don't know what our hypotenuse length is, so that means we're not going to use it. That means that we can't use SO and we can't use CA, so we are going to use TOA, tangent. So tangent, let's see, tangent equals opposite over adjacent. So we have our opposite, so we're going to use our tangent of 15 degrees here, equals our opposite, which is 10.2 over BC. We're going to use the name of the line BC. So we have to solve this to make sure that we can, we first need to solve it out to get it to be BC equals. We want to know what our line length is. So I'm going to multiply both sides by BC. This is just basically solving an equation for a variable. So we have BC times tangent of 15 degrees equals 10.2. So then I want to divide my tangent of 15 degrees to get BC by itself. So our equation left over then is BC equals 10.2 divided by the tangent of 15 degrees. Now we can actually solve that. So we take our 10.2 and divide it by the tangent of 15, and BC comes out to equal, and it says rounded to the hundredth, so 38.07, and we're working with our units of feet. So 38.07 feet. Okay, this is a good caution. Don't round until the final step of your answer. Use the values of the trigonomic ratios provided by your calculator. So if you round, your answer will be off slightly, and we need to make sure that it's specific. So we're going to not round till we get to the very end. And you should be able to plug the whole thing into your calculator and hit enter instead of taking the tangent of 15 degrees or taking 10.2 and dividing it by the tangent of 15 degrees. Okay, so Q and R, here's another one. So we're trying to find Q and R here. This one, we have our 63 degrees and we've got our hypotenuse here. So we now have got to figure out, okay, well, I've got my hypotenuse, and I've got the 63 degrees. I'm trying to find QR. So I'm going to be looking at QR and this one. So that would be the opposite over the hypotenuse. So hopefully you know by now that would be SOHCA. So opposite over hypotenuse would be sine. So the sine of 63 degrees is equal to our opposite, which is QR, over 12.9. Okay, so this one, we're again going to solve for QR, so we're going to multiply by 12.9 on both sides. So it becomes, I'm sorry, I'm getting a little messy here with the writing. Okay, so we have 12.9 times the sine of 63 degrees. All of that equals QR. So then QR is equal to 12.9 times, and we get 11.49 centimeters. 11.49 centimeters, and that is QR. Oops. Oh, there we go. Okay. There we go. Okay. Then we have for C, we're going to find FD this time. So we're looking to find FD. We've got 39 degrees. So FD we're looking to find is our hypotenuse. I'm done looking yet. Okay, so we've got 39 degrees. We have our adjacent and we're looking for our hypotenuse. So if we have adjacent and hypotenuse, you would, oh, sorry. Okay, adjacent over hypotenuse. So hopefully you would remember SOHCA, TOA. So that would be our cosine of adjacent over hypotenuse. So we have the cosine of 39 degrees equals 20 over FD. Then this is the one where we need to do some flipping around again. And I know you guys are very smart, big brain, as you like to say. So you would know that we could just swap if we multiply both sides by FD and then we divided by the cosine of 39 degrees. We basically are just swapping those two. So FD equals 20 divided by the cosine of 39 degrees. And when we solve that out, we get 25.74 meters. So hopefully that made sense. I know I went through that really fast with you guys, but hopefully it made sense. Okay, so I'm gonna actually just have you. I'm gonna pause the video, and I'm not really gonna work through these because I think then the video, I think you guys would be really bored with that. But I am gonna put up the answers. So if you want, pause now, and then I'll come back and share the answer. Okay, hopefully you had a chance to do this one. We're looking for DF. So in this case, you have, and we've got 51 degrees. So we were using the sine because we're looking for DF. So the opposite over the hypotenuse. And then you would solve that out. Again, you could flip those two and you get your answer of 21.87. So hopefully you guys got that answer. Okay, pause this video and do this one. Okay, hopefully you had a minute to do this one. Here's the answer to that. We're looking at cosine and 7.06. For C, you have the opposite and you're looking for the opposite and then you're looking for the adjacent one. So opposite over adjacent, so tangent in this one. There you go. Hopefully you got that answer. Then there is one more example here. I know it's a lot. I'm not requiring you to do all of them. I would pick two. At least make sure on all of them that you know what one you're looking for. Is it sine? Is it cosine? Is it tangent? Because the more you get used to it, the easier it's going to be. And you're going to be like, oh yeah, I'm looking for, sine in this one or cosine. Um, This one we have 27 degrees and we've got the hypotenuse and we're looking for JL, which is the opposite. So opposite over hypotenuse. So this one will be sine. And you'd solve it that way. So hopefully you did well on those 4 examples. For example 4, if you didn't, please go back and watch the example problems that I did before, or go back and look at these. If you need help and you're like, Mrs. Combs, I'm not sure what I'm doing here. Can you please help me on all the examples for A, B, C, and D? I can help you with that one. Or if you're like, I really need help on example D, I can help explain that one a little bit better too in more detail. Okay, this one is a real world situation here where we have the Plattersbahn in Switzerland is the world's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees. So we have I'm going to make our triangle here. And the steepest section, it says, is 25.6 degrees. And it says with the horizontal and rises of about 0.9 kilometers. So this is going to be our horizontal rise here. And it says how to the nearest hundredth of a kilometer, how long is this section of the railway track? So it's asking actually for our hypotenuse here. It's asking for the hypotenuse. Let's just say this is A, B, and C. So it's asking for AC here. I'm going to switch pen colors. So it's asking for AC, and we have our 25 degrees here. So this is our opposite over our hypotenuse. So hopefully you remember. So sine opposite of over hypotenuse equals 0.9 over AC. again, we're just going to switch those because we're going to multiply both sides and then divide. So hopefully you remember that AC is equal to 0.9 divided by the sine of 25.6 degrees. And when we solve that on our calculator, we get 2.08. So it's going to be 2.08. We're working with kilometers here. Okay, this one. Oh, this one I think is in your book. Let me just take a look for a minute here. Yes, this is the, it's not the same one. No, it's not the same one. But let me just write in the numbers here for you. I'll redraw it because that is a teeny tiny triangle right down there. So it says this is A, this is B, that's C. The degrees right here is actually 4.8 degrees. I don't like that. 4.8. And it says AB is 1.2 feet. So now we can go back to, we're trying to find AC, the length of AC, so the hypotenuse over here. So we have our opposite over hypotenuse, so we've got sine, opposite over hypotenuse. So the sine of 4.8 degrees is equal to 1.2 over AC. So again, we can flip those so that we've got AC equals 1.2 over the sine of 4.8 degrees. And when we solve that, we get 14.34 feet. The length of the ramp, 14.34 feet. All right, so here we are to the end of we're finding God in math. Scientists can use trigonometric functions to model and predict tides in order to help people better understand and use God-given natural resources. So in Genesis 1:28, God blessed them, he's talking about Adam and Eve, and said to them, "Be fruitful and increase in number, fill the earth and subdue it, rule over the fish in the sea and the birds in the sky, and over every living creature that moves on the ground." So God gave Adam and Eve all of this stuff to use and to have. And so same with the tides of the sea and the ocean, all of that stuff, God has given us that to use, and we can use it for his glory. And so we can use these trigonometric ratios to find out more about the world that he's given us. So I thought that was really cool and just a way to bring God into math. So think about that and how we use our trigonometric ratios. All right, so now your homework, I'm going to put on, it's going to be on the, oh, sorry. The homework is going to be put on there. It should be uploaded into your homework section there, so you can go ahead and go do that. Please let me know if you have any questions on this, and I will see you in the next video.